Hello everyone, welcome back. This is part 10 of the design patterns tutorials. In this session, we will discuss what is abstract factory design pattern, implementation guidelines of abstract factory, and we'll take a look at an example to implement abstract factory, and we'll also discuss the major differences between abstract factory and factory method. Please refer to the previous parts of the tutorial before proceeding. Let's take a look at the Gang of Four definition about abstract factory pattern. As per the Gang of Four definition, the abstract factory pattern provides a way to encapsulate a group of individual factories that have a common theme without specifying their concrete classes. To simplify, the abstract factory pattern provides an interface for creating families of related or dependent objects without specifying their concrete classes. Abstract factory pattern belongs to creational patterns and is one of the most used design patterns in real-world applications. We can say that abstract factory is a super factory that creates other factories. Now let's take a look at the implementation guidelines of abstract factory. We need to choose abstract factory pattern when the application need to create multiple families of objects or products, and when we need to use only one of the subset of families of objects at a given point of time, and when we want to hide the implementation of the families of products by decoupling the implementation of each of these operations. Now if you take a look at the illustrated diagram of abstract factory representation, the client is a class which uses abstract factory and abstract product interfaces to create a family of related objects. Abstract factory is an interface which is used to create abstract product. Concrete factory is a class which implements the abstract factory interface to create concrete products. Abstract product is an interface which declares a type of product. Concrete product is a class which implements the abstract product interface to create product. If this is confusing at this moment, don't worry, as we are going to take a deep dive on implementing these points using a simple example. Now let's consider a business requirement where a company decides to hand out computers to contract and permanent employees based on the designation and employee type with below specification. Let's say a permanent employee who is a manager is eligible for Apple laptop, and rest of non-managers are eligible for Apple desktop. Whereas in case of contract employee who is a manager, he is eligible for Dell laptop and rest of non-managers are eligible for Dell desktops. The above business requirement can be achieved by leveraging on abstract factory pattern. Now let's bring up the Visual Studio and learn how we can implement the abstract factory pattern with our previous working example. Let's open the employee table and add a new column called computer details. Let's define the data type as varchar. Let's make it as 250 and let's click on update. Let's click update database. Update completed successfully. Now let's switch to the models and open employee model.edmx, and let's right click on this model and update model from the database. Let's click on refresh, expand the tables, and let's refresh the employee table. The changes are updated successfully. Now let's create a new folder under factory folder. Right click, add new folder, and name this folder as abstract factory. Let's add some enumerations to support the business requirement. Let's right click and add new item, and let's choose the class and name this class as enumerations. Let's create some enumerations related to our business requirement. Let's first create public enum computer types, which are laptop and desktop. Let's create another enumeration and let's call this enumeration as brands. As we know that we need to hand out Apple and Dell brand desktops or laptops. Let's also create another enumeration and name it as processors, and let's create some processors as i3, i5 and i7. Let's now create abstract product interfaces which declares a type of product. So right click on Abstract Factory folder, add new item. Let's create an interface and name this interface as iBrand, which returns brand name. So let's name this method name as getBrand, and the brand could be anything, which could be Dell brand or Apple brand. Let's create another interface, add new item, choose interface, and let's call this interface as system type. This interface will have a method which returns the system type and name it as getSystemType. Let's make this interface as public. Now let's create another interface named iProcessor. Right click, add new item, choose an interface and name this interface as iProcessor, which returns a processor, and let's create a method getProcessor and make this interface as public. These three abstract product interfaces together compose a product, which in our case would be a laptop or desktop with the specified configurations. Let's now implement these interfaces into concrete product classes. Let's right click on the Abstract Factory folder, add new item, choose a class, and let's name this class as Mac.cs, which implements iBrand. Let's implement the iBrand method over here, which is getBrand, and let's return brands dot apple dot toString. Let's resolve this issue by using the enumerations, and let's return brands dot apple dot toString. Let's create another class. Right click, add new item, choose class, and let's name this class as Dell, which implements the iBrand. Let's implement the iBrand interface, and let's return enumerations dot brands dot Dell dot toString. To save some time, I have already implemented the iProcessor interface for concrete products, which are i5 and i7. I have also implemented the iSystemType to return the respective laptop or desktop as system types. Now that we have families of related products, let's create an interface which composes these products. Right click on Abstract Factory folder, add new item, choose an interface. Let's name this interface as iComputer Factory. Let's add the products that we have created to this interface, which are iProcessor. Let's name this as processor, iBrand, brand, and iSystemType as system type. Now let's create concrete factories which implements this abstract factory interface to create concrete products. Let's right click on this abstract factory folder, add new item, choose class, and let's name this class as Mac Factory, so that it creates Apple laptop and desktop. Now let's inherit the iComputer Factory and implement the interfaces. Now when we need to create a Mac Factory, let's say this is creating a new desktop, then the brand would return as new Mac as the brand, and the processor would be i7. So let's say we will be creating a Mac desktop with i7 processor, i7, and the system type would be return new desktop. Let's also create a Mac laptop factory. So let's create it over here, public class Mac laptop factory, which inherits iComputer Factory. Now let's implement the interfaces, implement interface, and let's say the brand will be return new Mac, and the processor will be return new i7 processor, and the system type will be return new laptop. Now if you observe the Mac factory and the Mac laptop factory, both has got the same brand as well as the processor. The only difference between these two is the system type. So let's refine it further, and instead of inheriting the iComputer Factory for Mac laptop factory, let's inherit from the Mac factory. Let's say Mac laptop factory inherits the Mac factory, and let's remove these implementations and change this implementation as virtual system type, so that we can override it here. Let's now create concrete factories which implements the abstract factory interface to create Dell products. Let's right click on the abstract factory folder, add new item, choose class, and name this class as Dell Factory, which inherits from iComputer Factory. Let's implement the interface methods, implement interface, and let's return new Dell as the brand, and let's return the processor as i5, return new i5, and let's return the system type as return new desktop. Let's now create a laptop factory for Dell similar to the Mac laptop factory. Let's say public class Dell laptop factory, which inherits Dell factory, and we just need to override the system type. So let's declare virtual over here and public override system type, which is system type, and let's return new laptop. Now that we have implemented the abstract interfaces as well as concrete implementations to those abstract interfaces and products, let's see how we can address the business requirement. Right click on the abstract factory, add new item, and choose a class, and let's name this class as employee system factory. Let's create a method public which returns iComputer Factory, and let's call this method as create, which accepts the employee as the input parameter. Let's resolve this issue by using web.models. Let's declare the return value as iComputerFactory return value equal to null if e dot employee type ID equal to 1, which means he's a permanent employee. Then if the employee's job description is manager, then for all the managers we are going to give laptop factories of Apple, which means return value equal to new Mac laptop factory. Other than managers, we are going to return or assign the return value equal to new Mac factory. That means all the Mac desktops. Now if he is a contract employee, which means else if e dot employee type ID equal to 2, which means contract employee, then if e dot job description equal to manager, we need to assign the return value as return value equal to new Dell laptop factory. Else return value equal to new Dell factory. Let's return the return value. Return value. Now let's create a client class which will be responsible to derive the system details based on the created concrete factories. Let's right click on the abstract factory folder, add new item, choose class and name this class as employee system manager, and let's create a iComputer factory underscore iComputer factory as initializer. Let's create a constructor public employee system manager which accepts the input parameter as iComputer factory and let's assign underscore iComputer factory is equal to iComputer factory. Let's create a method public string get system details which uses this iComputer factory and retrieves the respective brands, processor and system type. Let's say iBrand equal to underscore iComputer factory dot brand and iProcessor equal to underscore iComputer factory dot processor, iSystem type system type equal to underscore iComputer factory dot system type. Let's assign the return value as string return value equal to string dot format of 0 and 2, which means brand dot get brand comma system type dot get type and processor dot get processor. Return value. Let's resolve this error by making this iComputer factory as a public interface, public, and let's switch back. Let's rearrange all the classes under the abstract factory folder based on the representation diagram which we have illustrated in the starting of this tutorial. Let's create a folder, abstract product, right click, add new folder and name it as abstract product, and let's move iBrand, iProcessor, iSystem type under the new folder. Let's create a folder called concrete product, right click, add new folder and say concrete product, and move all the concrete product implementations under this folder, which are Mac, Dell, processors and computer systems. Let's create another folder, add new folder and name this folder as concrete factory, and let's move implementations related to abstract factory interface. So let's move Mac factory, Dell factory and employee system factory into this folder. Let's create another folder and name this as client, new folder, client, and let's move the employee system manager under this folder. Let's also create a folder named abstract interface and let's move iComputer factory underneath that. I hope now you are clear with what we have implemented till here. Let's now integrate these changes and implement the requirement in the employees controller. Let's open the employees controller. Let's create the abstract factory here. iComputer factory equal to new employee system factory dot create, and let's pass the employee as the input parameter for the create method. Now let's use the client which we have created, which is employee system manager equal to new employee system manager, and which accepts this abstract factory. Manager dot get system details will retrieve the respective systems that we are handing off to the employees. So let's say employee dot computer details equal to manager dot get system details. Let's now switch to the views, expand employees, and let's go to the index view and let's add this new column that we have created in the header, which is model dot computer details. Let's also add this in the table data. Let's use the existing one and change this to computer details. Let's compile this application and let's run this application. Let's click on employees and create a new employee, the name as George, job description as manager, P3456 as the number and department as IT. Let's choose the employee type ID as permanent and let's click create. Notice that George, who is a permanent employee and a manager, is allotted an Apple laptop i7. Let's create another employee and let's name the new employee as Sebastian, and let's put the job description as developer and the number as D2345, department as IT, and let's choose employee type as permanent here as well. Let's click on create. Look at that. Sebastian is created as developer with a computer details as Apple Desktop i7. Now, before creating a temporary employee, let's try to debug this application and see how it behaves. Let's put a breakpoint over here at the create method and let's run through this application. Let's create a new employee. Let's name this employee as Andrew. Job description as manager, number as C3456, department as IT, and let's change the employee type to contract. Let's click on create. Now let's step into this code. Notice that since the employee type ID is equal to true and the job description is manager, we are creating a Dell laptop factory and we are returning the abstract factory back to the client. Let's step in through the client. Look at that. The abstract factory is getting initialized over here, and then we are invoking the get system details, which invokes the respective brand, processor and system type and retrieves the corresponding values. Let's press F5. Now notice that Andrew, who is a contract manager, is allotted with Dell laptop with i5 configuration. With this, we have successfully addressed the requirement by using the abstract factory design pattern. Now let's take a look at the major differences between abstract factory and factory method pattern. The abstract factory design pattern adds a layer of abstraction to the factory method pattern. Abstract factory pattern implementation can have multiple factory methods. Similar products of a factory implementations are grouped in abstract factory. As you have noticed, abstract factory uses object composition to decouple application from specific implementations. Factory method uses inheritance to decouple applications from specific implementations. I hope now you got familiar with the abstract factory design pattern. In the next session, we will discuss and learn another creational pattern. Please feel free to post your comments and feedback in the comment section. Thank you for listening and have a great day.